Hi everyone. So today's problem of the day is maximum path score in a grid. What is given in description? You are given a m cross n grid where each cell contains one of the values 0, 1 or 2. You are also given an integer k. You start from the top left corner 0, 0 and want to reach the bottom right corner, that is m minus 1, n minus 1 by moving only right or down. Each cell contributes a specific score and incurs an associate cost according to their cell values. If the cell value is 0, that means it will add 0 score and it will cost also will be 0. If the cell value is 1, then the score will be 1 and the cost will be also be 1. If the cell value is 2, that means 2 will be the score and the cost will be 1. Return the maximum score achievable without exceeding a total cost of k, or minus 1 if no valid path exists. Note, if you reach the last cell but the total cost exceed k, the path is invalid. So what is given in the question? We will be given a grid, and that grid is having n number of m number of rows, and it will be having n number of columns. And that grid value, in the grid there is cells. So for any cell the value can be 0, 1 or 2. If the value is 1, that means if we are going through that uh, grid value, grid cell, then it will add 0 score and the cost will also be 0. If the value is 1, then the score will be 1 and the cost is also 1. And if the value is 2, then the score will be 2 but the cost will be 1. And we need to find the maximum score, but our cost should not reach greater than k. It should be less than equals to k. And if reaching the last cell, after reaching the last cell, if our including this cell, if our cost will be something x which is greater than k, then that path will be considered as invalid. And in invalid case, we can return minus 1. If we are not able to find any valid part, we can simply return minus 1. So seeing the constraint is it is given m and n. M and value can go till 200. K will be less than equals to 1000. And the grid 0, 0 is always 0. And this grid value can start from 0 till 2. So seeing the constraint, like if you will be given some grid value and you need to start from bottom and reach till end, then if you will traverse, you can traverse right or you can traverse down. So to traverse right or down, suppose you are taking one path like this, right, down, right and down. This is your first path. And second, you will do something like down, right, right, right and down. So if you will see in your first path, after you reach this point, you are following this path. And if you are starting from this and going to down, and after reaching at same point, you are doing this, you are traversing to the same path. So you can see there is the recursive, like we can use recursion here because there you can see there are the repetitive cases, because the solution is repeated, and to decrease the time complexity we can use something DP or something, but initially we will be using recursion. But that one thing clear in our mind, that we need to use recursion because there will be repetitive cases in this question. And generally in grid we will be using recursion only. But seeing the constraint, it is mn should be less than 200. If you will see the constraint, mn should be less than equals to 200. That means if you will do recursion, the time complexity will be something exponential. And if you will do something 2 to the power something mn or something, it will go, it will be much greater than equal to 10 to the power 8, and we can get DLE easily. So we need to use DP here. Now if you will coming to the first example, we will see how we can use DP here. And if you know, there are two kind of DP, top down and bottom up. We can see what is the difference between two and which DP we should use here, and this we will see it later. So for this, for now, if we, I will see the for the first example, there is grade 0, 1, 2, 0. My k value is 1 and I am starting from this. If I am starting from this cell, then if I will go to this way, like right and down, then my cost will be 1 and my score will also be 1. If I will go to this way, then this is 0, this is 2 and this is 0. So in this case, since this is 2, so for this my cost will be 1 and score will be 2. So in both cases, our cost is 1 only and our cost should be greater than equals to k. K is 1. So in both cases, we are getting cost 1 only. That means both are valid. And what if we see, will see the maximum score, in one case we are getting 1, in one other case we are getting 2. So we can simply return 2 in this case. In my second example, what is given? 0, 1, 1 and 2 and k is 1. If I am going through this way, then if I will reach here, my score will be 1 and cost will be 1. Now coming here, uh, for now my score is 1. For after reaching 2, it will be 1 plus 2, that means 3. And this cost is initially 1 and 2, so it will add one more cost. So my cost will be 2. If I will go to this way, 0, 1. So for when I will reach 1, my score will be 1 and my cost will be 1. After reaching 2, my score will be added 2 and cost will also be 1. So score will be 3 and my cost will be 2. In both cases, if you will see, score is 3, 3 only, cost is 2, 2. But if you will see, our cost should be less than equals to k. But here we are getting cost greater than equals to k. That means we are not able to get any valid answer. So these are invalid cases. So we can simply return -1 in this case. Now, if you will see, we have, I already spoke, like we have two ways to do top-down approach and bottom-up approach. So we will be doing with this with the help of bottom-up approach. We are not doing it with a top-down approach. We are not doing this because if we will try to do with this now, then it will add stack space also extra, and because of that a time complexity will reach and we will be getting TLE, like not TLE exactly, memory limit exceeded we will get. So we will be using bottom up approach here. So what I done here, I basically initialized my rows and column. Then DP, I initialized DP. My DP is my 3D DP. So this will be my row, this will be my column, and this will be my cost. So in bottom up approach, what we're basically doing, the bottom up approach means after initializing the DP, we will be using our base case. So what will be our base case in this case? It's DP of 0, 0, 0 equals to 0. Why it is 0, 0, 0 equals to 0? Because when my column row and column value is 0, 0, that means when I am at 0, 0 cell and my this what I call cost is 0. So in that case, my this maximum score will also be 0 only. This is the case when I am at this cell. When my this row and column is 0 and cost is also 0, then in that case, my score will also be 0 only. Then I will be starting from 0 to less than m for the rows. This for the columns, and this is for my cost, that I can go from 0 to less than equals to k cost. If my dp of ijc is equals to -1, I initialize it with -1 and If I'm getting my value as -1, that means I have not yet traversed that cell. So if I'm not yet traversed that cell, that means I can do continue. And if it is not equals to -1, that means we have already traversed that cell, and we can able to find the right and down value for that cell. If I am from that cell, if I am moving down, down means I plus 1 for my for current case my row is I. If I am doing I plus 1 means moving down. If it is less than m and less than m, so m is the number of rows, then I will calculate my grid value, and according to grid value, I can calculate my cost. If my value is 0, then my cost will be 0, otherwise my cost will be 1. So I can calculate my new cost if my new cost is less than equals to k, because in our case, our cost should be less than equals to k only. If my cost is less than equals to k, then I can calculate my dp of I plus 1 for new row and new column and new cost. I will calculate my value. It will be maximum of that value if that value is having some previous value, and dp of ijk from the previous. This is indicating the value for the previous row and column plus that value, because that value is shown, that value is for the current cell. So it will give me my maximum value, and it will get stored in my dp of I plus 1 j and new cost. Now in the same way, if I will move right, so for my right, j plus 1 is less than n. It will show that I am within my grid. So I will calculate my value. According to value, I will get cost, new cost, and it should be less than j. Then I will calculate my new row and new column value. Correspondingly, I will maximize this value. And at the end, I will calculate my maximum score. Maximum score means after I will reach my m minus 1 comma n minus 1 cell, then I need to calculate my maximum score. So dp of it will be m minus 1 only, because I am calculating for m minus 1 comma n minus cell, and this column will be n minus 1, and c will change from 0 to k, because it is possible that I have used my zero cost, or I can use my k cost till k cost I can use now. That's why I'm looping it from 0 to k, and at the end I can return my answer. So yeah, that's it. Thank you.